So let me come back with the internet protocol. An internet protocol address is nothing but it's actually a unique set of numbers assigned to each device connected to a network, which we have already seen in the last video. So any device which will, if I say it is unique, it should have a different name or different address, as how we are having for a different address for our home. The same case, if you take any computer, any phone, or any other device, it actually, for if we are doing a communication without the IP address, we can't do the communication. So that's what, if we are visiting a website, you need a URL, that is IP address, to connect to the website server. Next is, what is IPv4? IPv4 is nothing but IP Internet Protocol version 4, which consists of two things. One is the network address and the host address. IPv4 addresses are holding 32-bit integer, which have to be expressed in the decimal notation. Say for example 189.123.123.90. So this is how we can represent in the IP address in the binary form. What is the drawbacks in using IPv4 is it has limited address space. Just it has 32-bit integer, which is not enough for this IoT to make any improvisation. This protocol is not suitable for IoT. The next is complex configuration. It has manual configuration or DHCP. Every time I need to make a setup for connection, I need to make a setup every time, which is a time consuming process and it may lead to error prone. Less efficient routing. Routing in the sense, we have n number of routing protocols. The data has to be passed through all the network and it has to be reached to the destination properly, since it is not happening in IPv4, and the header is more complex, which can slow down the data processing and routing. Security issue, which does not have any built-in security features, so attacks can be easily happen. We need extra security for internet protocol. And limited support of quality of service, has limited capability for prioritizing certain types of data which can affect the performance. And the next is fragmentation, which allows routers to fragment packets, which leads to inefficient and increased chances of data being lost or corrupted. And broadcasting overhead, which uses broadcast for communication with n number of devices or multiple devices. Unnecessary network traffic it will create, which reduce the performance. The next is the advanced version of IPv4, which is nothing but IPv6, where predominantly we are using this IPv6 for the IoT technology. It is actually the advanced version of IPv4 and it's a new version of Internet Protocol, which is a way better than IPv4 in terms of can say it as a complexity and efficiency. IPv6 it actually written in 8 hexadecimal numbers, which is separated by colon, and the address it holds is 128 bits, that is zeros and ones. So this is the best example for the 16 bytes IPv6. Now we can see the comparison of IPv4 and IPv6. First we will see the address size. It has 32-bit and it has 128 bits. Address format is, it has dotted and it is colon, I mean hexadecimal. It is dotted decimal and it is hexadecimal. And address space, it can have up to 4.3 billion addresses. It has about 340 undecillion address, and NAT reduced due to address shortage. This NAT is not needed since we are since we are not using manual DHCP, and IPsec support is optional. It is security is built in IPv6, and auto configuration. We need to set up connection every time when we share the data. It is automatic address configuration, and header complexity is complex in IPv4 and it's very simple in IPv6. And fragmentation, it is handled only by routers and handled by sending host only. So these are all the advantage of comparison of IPv4 and v6.